there, geometry students. This is Mrs. Hefty here, and we're continuing in Chapter 4, which has been on triangles and triangle congruencies. And so today we're going to look at congruencies of transformations. And this is where you have an original figure, and then you have another figure or a pre-image that has been transformed, and it's still congruent. And so our transformations, our first one is called a reflection, and you do have reflection written on your paper. It's where the image is taken across the y-axis. So my original figure is right here, and I've reflected it over the y-axis. The second one is a translation. You also have that written on your paper. And that's where I'm just moving the figure. So here's my original figure, and I'm just moving it down. I'm translating it. And then our last one is a rotation. And a rotation is like a turn. So here's my original one, and I'm turning it over the origin. All right, so let's take a look at a couple examples. The directions say identify the type of congruency transformation shown as a reflection, a translation, or a rotation. The pre-image is the darker and the lighter is the image, okay? So I guess here, this is my original, and then this is going to be my pre-image. Is what it says there. After I've moved it, that's the pre-image. This is after you've moved it. Okay, write that down. I'm going to be looking for that when I check your notes. The pre-image is the image that is there after you've moved your original. And in the book, it says that the pre-image is the blue and the image is the green. So remember, pre-image is the one after you've moved it. So when I look at my original, what have I done here to move this pentagon to this spot here? I have just translated it. I've moved it over and then up. So this is a translation. In example number 2, I'm looking at my original, and then this is the pre-image or the image after I've moved it. And this time it looks like it's been rotated, so it's been moved so many degrees, so this is called a rotation. See how it's kind of been flipped around? You also can have more than one answer here, so as we move on to our next one, I'm looking, and again, this is my original, and this is my pre-image, and I'm looking, and I see this rhombus, and it's being moved over, which is a translation. Because it's identical, it's equal on all sides and angles are all equal as well, it could have been a rotation. I could have been rotating that around. And then you also see that here's my y-axis, that it could have taken and flipped that over the y-axis, so it is also a reflection. So keep that in mind when you're doing your homework. You might have more than one answer. All right, so in this section we're talking about congruency in this whole chapter, and so now we're going to verify congruency transformations. So my transformations are going to be the same size, so I want to prove that they're congruent. And so we've done this before, proving things that are congruent and using SSS. I'm going to use my postulate SSS, and I'm going to use the distance formula. So let's take a look here. We have to graph triangle WXY, and then I have the vertices there, and then I have the triangle RST, and I have those vertices as well there. And then I need to identify the transformation, and then I need to verify that it is a congruency transformation. So what I need to do is write this down, find the distance of the sides, and I'm going to prove using SSS. So let's go ahead and graph those. My W is 3, -7. There's W. My X is 6. -7. And my Y is 6, 2. Okay. And then I have my triangle RST with R being 2, 0. And then my S is 5, 0. And then my T is 5, 5. All right, so first off, I need to decide what kind of transformation do I have. It looks like I have a translation. I'm just moving it. I'm not going over the y-axis. Just moving it up. All right, and so now I need to find all of my line segments. So I need to find RS. Now I can count RS here, and I can see that's 3, so I don't need to use my distance formula. The piece in the triangle below is the same, which is WX. That's the corresponding side, and that is also 3. If I cannot count them, I have to use the distance formula. I can count that one right there, which is ST, and that is 5. And what corresponds with it is, I forgot my letter there, XY, and that is also 5. And then now I need to do my RT, and because I cannot count that, I'm going to need to use my distance formula. So I'm going from R to T, so I'm going 2 minus 5 squared plus 0 minus 5 squared. RT equals, I'm communicating my mathematics, I'm showing my work, -3 squared plus -5 squared. RT equals, I'm getting 9, square root of 9 and 25. So my RT equals root 34. Now, if I need to simplify that radical. I'm not going to write a decimal down. 34 cannot be simplified, so I'm going to leave that in radical form. All right, I'm moving on to WY. Same thing, I'm going to use my distance formula. So W, I have 6 minus 3 squared and a -2 minus -7 squared. So WY square root, that's going to be 3 squared, plus a -2 plus 7 is 5 squared. Okay, this is making me happy because I'm getting the same numbers. WY square root 9 and 25. So my WY is also square root of 34. I'm proving that my transformations are congruent transformations, and so again 34 cannot be simplified. So when I look here, I am getting congruent sides. RS and WX, ST and XY, and then I have my RT and my WY. So I can go ahead and say now, and this is part of your answer, people, make sure you write this down. I'm running out of room, but triangle RTS is congruent to triangle WYX by SSS. So you need to make sure that you're communicating that. All right, well, you guys have a great day, and I'll see you in class tomorrow.